Hello, my name is Mark Silver. If you're watching this video, it means you've probably bought a receiver from iGx. We thank you very much for doing so. Today we're talking about the iGx download tool. This tool is used for downloading static observation files from most of the iGauge and CHC receivers that we've sold over the years, going back to the very first receiver, the X90D, which no longer works. Anyway, the current version of this tool is 9801 or 2, depending on when you download it. I just want to show you some of the cool tricks that this tool is capable of doing. I've got a couple of customers' observation files here. When we start this tool and you install it, it originally comes up in the simple mode. And to start out with, the first thing I would do is come down here to where it says Show Advanced Settings and change that to Expert. Go all the way to Black Diamond. Lots of extra buttons. The buttons are good and more's better. So the next thing you want to do is if you click this default button, it's going to allow all of these checkboxes for GPS, GLONASS, Galileo, and Beidou. So it's going to select RINEX 3.04. Don't ever use RINEX 2.1. unless you absolutely have to. In fact, this program, every single time you choose RINEX 2.11, it will beg you, force you to use RINEX 3.04 every single time. Trust it, it's the right decision. You want to set your decimation to 30 seconds. I used to think that at some point NGS would use 15-second decimation for OPUS, but it looks like they're stuck on 30 seconds. So there's no reason not to. If they were ever to change to 15, you could reprocess your files, generate 15-second epochs, and resubmit them. There's a bunch of other stuff here. Usually you want your times to show up in your local time, so uncheck the Show UTC button. And then let's come back to occupations, and I'll show you if you pick a solution, an observation here. Here's a 3-hour and 20-minute observation. You can right-click on this line and choose Show in Google Maps. And it'll drop you in and put a red flag at the place where the a priori position is for the job. Now, this is the autonomous position for the receiver. It's accurate to probably a meter horizontal, which is plenty good enough. So when we're looking at customer jobs, we're always told by the customer that they would never acquire data under a tree. However, we know from experience that that's not always the case. If we zoom in here, you'll see that this job was collected between the sidewalk and what appears to be an island, landscaping island, over here, and there, surprisingly, is a tree to the south. We're going to see this later probably when we process this job. Look at the QC on it. We can always bring our little guy over here and set him down. And oh, okay, so see this observation was done right over here where my finger is pointing between this landscaping aisle, and the south is pointing directly to the right. So there's a house to the south and there's a tree to the south. Of course, we don't know if the leaves were on the tree when this was acquired or not. Anyway, so that's what happens if you push the Show in Google Maps button. Now, the next thing you can do with this tool is we can map out core stations. And we do that, you can either right-click and choose Core Station Helper here, or you can come over to the Configuration tab, come down and click Station Helper here. I'll do it from here. When you do this the first time, it's going to ask you if it's okay to download the current station list from the NGS website. I'm going to do it now. It doesn't take very long. And then what it'll do is it'll rank by distance all of the nearby core stations, and you can see some of them are 38 kilometers away, and some of them are in New Zealand, 13 million meters away. So we can take and look at these sites, and we can right-click on them and say, well, let's look at the short-term plot. This is probably the best plot. This is a good station. I can tell by looking at that plot. let's come down. I think this PAFM, I've used this one before. And the short-term plot, yeah, this one's crap. You don't want this station in any OPUS solution that you use, ever. So you can right-click and choose exclude this station. And it'll put it into this excluded station list at the bottom. Let's see, I think there's another one. Yeah, this one right here. Let's look at this station. Yeah, this one's crap too. So we'll map that one out. Now I believe NGS has a limit of 6 stations, and you can either use them all for excludes or you can include some stations. If you include stations, it's kind of dangerous because if there's no data from that station that overlaps your observation, then the OPUS submission will fail. So I typically only exclude stations. And OPUS does a good job of excluding them on its own, but a lot of times if you don't exclude a station, your OPUS submission will fail because OPUS assumes that all of the core data is perfect. So if there's a non-matching or a damaged baseline, it's obviously your receiver, not the core's receiver. But we just saw there's some bad receivers here. Let's take a look at one of these and see if we can figure out what's up. So we can right-click here and we can look at the NGS core station website. We can see photos of where the station's at. So looks like these are all turned the wrong way. Whatever. Let's see. Oh no. I guess we're standing at the station here and looking someplace. Let's look here. Oh, okay. Well, that's kind of a flimsy mount, I would say. Looks like a nice building though, but the mount is probably not. Stainless. Okay, not going to say anything bad about this mount other than what I've already said. So there's some wacky going on this. Now, if you want a larger overview of this station's quality, I cannot highly recommend enough the NGL's station page. So they maintain these for most of the stations. And it defaults to an iGx 14. So this is a current epoch world-centered reference frame. And you can see that the North American plate is moving. That's good. We can go to the North America plate fixed, and you'll see that the movement goes away mostly. There's also a quality assurance down here. Wow. Okay, we won't talk about what these things mean, but you can get on here and poke around. And well, this actually doesn't look bad, but this is kind of a shit show here. So we decided not to use this, and I think that was reasonable. You can also look at station availability here. So if you click this button, you'll get the previous 7 days. And then if you want, well, we'll come back in a second and look at that. So that's what's up with this core station helper. It's here primarily to help you exclude core stations that suck. You can also, from here, view the raw file header. So this is the first 1,024 bytes of the HCN file, which is the raw file that all these receivers make. You can also view the RINEX file header. So this is the RINEX that's generated from the HCN file. Look at the header here, lots of interesting information. And you can look at the entire RINEX file. This is probably a fairly large file, so I'm not going to open it. You can force the agency operator. So when it forces these, it comes over and gets the default agency and the default operator. Now, if you don't have an agency code, you can request one. Click this button and it'll take you to the NGS website page that tells you where or how to get an agency code. iGauge's is IGA. And you can move this observation to a project. So for instance, we could make a project with the name Hink Street and take this and move it to Hink Street. You can also push this button down here. You can make new projects down here. I'm going to keep it in the new project, which is special. When you're in the advanced mode or the expert mode, you get the starting and ending times, the file length, the recording interval, and you get the approximate position. This is the a priori position of the file. Down here you can set the instrument height, and you probably know that if you put in slant measurement, this tool knows the slant measurement height offset and radius, and it will compute the vertical height, although I always collect data on a 2 meter or fixed height tripod. There's a QC button down here, and it works most of the time. However, when you push this button, it converts the file to RINEX 2. And if the file has, and it does that with TEQC and then does a TEQC QC run, if there's a high numbered beta satellite in the job and it's not trapped out successfully, TEQC will fail. And this is why you never want to use RINEX 2.0. Anyway, in here you can see when the file, you can see the tracking up here at the top of this graph. There's some information. An important line here is the QC minus header position right here. So TEQC goes through, takes the ephemeris and calculates a probable location for the file, and then it compares it with the a priori position, which is in the header file, and it's in there in ECEF. These are these values, which are then converted to latitude and longitude. Now, we expect about 1.5 meters. That's the difference between ITRF 2014 and NED 83 currently for North America. The elevation offset is usually quite high, and that's a function of the calculation of the elevation. Don't worry about it. We got the interval here, a summary of the satellites that were tracked, and then down here a little lower, there's a line that's labeled summary, and the things we want to look at is the number of expected and the number that we have, and 72% is kind of low. That might be because there was a tree to the south and a building. Also, the MP1 and MP2 are a little high, and the observations per slip is fairly low in this case. And again, that's because it's taken under a tree. So if you come down here to the very bottom, there's some graphs, and if you look at enough of these, somehow you just know that this is pretty good. Not bad, really, but if you look up here, you'll see, well, these things right here, these are those trees to the south, these slips that occurred in these elevation bins. Anyway, that's a QC run. We use these extensively. What we use them for is sometimes some of our customers will turn the receiver on the tailgate of their pickup truck, let it run for a few minutes, and then walk over and spin it down on their tripod while it's running. So they've got like a dynamic section of the file at the beginning. We need to trim that off. And how long do we trim off? Well, at the end of the file, sometimes some of our customers will forget to turn the receiver off. So they'll take it off the tripod, walk it over to the truck, put it in the box, close the lid on the box, and drive back to their office. But the receiver is running. So they end up with an 8-hour file when it should have been 2 hours or 2 hours and 30 minutes. So you can come into this trim box here, and you can trim off part of the front of the file and part of the end of the file. And if you need to know what the nomenclature here, push this question mark and it'll tell you. Anyway, when you do this, if you're in the expert mode, in the center here will tell you the resulting length of the observation after the post and pre-trim are removed from the file. So we use this all the time, and if you're perfect, you'll never need it. So those are kind of the secrets that are here on this first page. Let's take this job and submit it to Opus right now. I'll show you we've got direct OU submission unchecked, and we've got the beta page unchecked. So when I click submit to Opus, it's going to prepare the file, which is decimation, and it's going to also zip it. So it's taken a 50 megabyte file and zipped it down to a half a megabyte. We do that because there's no reason not to, and it's going to transmit to the NGS faster. So then you click on Submit to Opus. I'm sure you've all seen this, and you get this is the actual NGS web page for submission. What we want you to do is put your cursor in the file name box here, hit Control V, which is paste, and click on Open. And then we used to be able to pick the antenna type, but there's no way to automate the selection of this box, so you need to type in enough to characterize the antenna, and then you have to click on the blue line down here. You'll see that it's already filled in the 2 meters. It's put my email address here. It's requested an extended output, and it did not pick to the exclude. Well, I'm not going to submit this anyway, so it should have put the excluded things in here. We'll have to go look and see what's up with that. And then down here at the bottom, it tells you the antenna type if you forget, and then here it says click upload to static. So we would push this button. Now, if I'm not talking, I can, press Control V, pick the antenna, look through it, and do it in 30 seconds. And it's good. We want you to see what that file looks like, or that form looks like. But if you come over here, oh look, I didn't hit OK. So we need to go to Station Helper, and we need to knock off PAFM. And we also want to do WBV. This one sucks too. Click OK. So now they're here. Anyway, that 30 seconds it took me to fill out the form, unacceptable to me. I'm in a big hurry. So check this out. Click on this Use Direct OU Submission, and then come back over here. We'll click Submit to Opus. And this tool will spawn off a different tool, which is called Opus Upload, and it'll take that file and push it up to the NGS. But it makes all the selections for us, so we don't have to pick any antennas. And we're done. So it hangs out on the screen for 5 seconds, and then it goes away. Now, currently, at the time when this video is being made, there is a beta version of Opus, and it uses all constellations. So it uses GPS, GLONASS, Galileo, and Beidou, which is great because it's going to take an occupation like this that was collected maybe under a tree, maybe not, and it's going to make it cleaner. So let's take a look at what we need to do to submit it to beta. Well, you can just check this button right here and come back and click Submit to Opus. And this will take this file, prepare it, and ship it off to Opus, but send it to the beta page. The checkboxes here, well, you can't see where I'm pointing, can you? The checkboxes here are mirrored from the configuration tab over here. And the exclude list is already filled in, and the height and the email address. So that's pretty neat, I think. Over here on the configuration tab, there are a few other things. So remember, we were looking at UTC times, or we were looking at local times. If you click this, you'll see UTC times, which is very nice if you need to manually download files, because they're all expressed in UTC times or GPS time. Down here, you can get to the RINEX converters manually. So that's also very handy. And then there's a button here to mark files that are on the GPS receiver that have already been downloaded. You can mark them as being new files, so they'll be downloaded again. Now on the new receivers, these are read-only receivers, and currently it's the I-89, I-93, and iBase. The drives on those are write protected, so we can't mark the files as being downloaded. So what we do on those devices is we keep a list of what's been downloaded and what hasn't, and we give you some tools that will manage them. And it should be obvious. I might make a video on it later. There are also some receivers like the iBase, which do not have a USB port on them. So in those, we have to make a connection via Wi-Fi to them, and then we use an FTP download. And this tool also automates that entire process, but that's another video for another time. You can look at the version notes here. Click this button, bring up the version notes, and the latest version stuff is here at the bottom. So there's that. And you can also clean up a GPS receiver. So if you have an IG8, IG9, X91, X90, any of the receivers that are not read-only or FTP, you can push this button in. Any of the observation files that are older than, I think, 90 days will be copied to a special secret directory on your PC, so that there's an extra backup of them compressed, and then they'll be deleted off the head. Which reminds me, over here on this button or box, there's this, clean up the new observation project list. So sometimes I'll remotely log into a customer's computer and they'll have 10 years worth of observations, literally. 4 observations a week for 10 years lined up in this list. And it takes this tool, I mean, there's thousands of them. It takes this tool 5 minutes to load. And if you were to manually try and clean it up, I don't think you could do it. So if you push this button, what it does is it takes the files from, say, 2019, and it puts them in a project called 2019, and takes all the files from 2020 and puts them in a project called 2020, and all the ones from 2021 and 22 and 23, and anything that's more than 6 months old and 24, but there aren't any, it's first month is January, so there won't be any of those. Anyway, it takes those files and organizes them in individual projects by year, trying to get the size of this list down to something manageable. And once you get those projects, so let's come to maybe some data in. There's not going to be any data in any of these. But once you get these projects, you can select them, and then you can save the entire project into a single zip file with the archive button here. There's an archive button down here that will archive just the currently selected occupation. And then over here, there's an archive button that will archive everything. And this button and the project buttons could take quite a long time to complete if you push them. And this button here that cleans up this list here can take a while to complete also. So this button here, MSS, will download a tool. Let's do it from the internet, and then it will run the tool, and a little box will come up, and after a while it will give you a 4-digit passcode. Presumably you're talking to one of us here at the office. And look, I'm going to put on my headset here. So I've got my headset on. See, I look like the guy on the send button and the MSN button because I got a headset on. Anyway, if you were to read me this 8685 number, I can put it in on my computer, and then I can connect to your computer, and I can see your screen, and I can also remote control it, which is invaluable when we get customers who get things really messed up. Anyway, that's what that does. And to make your computer safe, click that button there. And now your computer can't be seen by others. So it's back as safe as it was before we connected. That's that button. This button right here will take whichever observation is selected, and it will zip up everything about that observation, including your email address, into a single file, and it will push it to the internet server in the back closet at iGx. which is handy because then we can take your entire file set and put it into the iGx download tool that we're using now. And in fact, that's how I got both of these files. And then we'll see exactly what you're seeing. We'll have everything from your job. This takes a while because the files are big, and this zips them up, and then it sends them off through the internet to the back closet of the office. So the folder on the computer at the office has thousands of files in it. It's like grains of sand at a beach. So when this is finished, it's going to give us a file name. You have to tell the person at iGauge what the file name is, and you have to tell them it's there because we don't know. But if we know the file name, or we know that you just sent it, we pick it up by date, then we can go find your grain of sand on the beach, and then we can bring it and stick it in our version of iGx. So while this is being uploaded, we can go back, and remember I told you that you could get data availability, and here's what that screen looks like, and you can see that this station, PAFM, reports hourly. We know that because it's got a little blue tick mark here. So it's got 1 hour's worth of data. So it must be after 1 a.m. UTC. Some of the stations report daily instead of hourly, and you'll only see these bars fill in with blue a bar at a time. So I think that's everything of interest in this download tool. When you go to upload it, by the way, it looks like nothing's happening, so you just have to be patient. It says not responding up here, I know that, but it's uploading 76 megabytes, I think. So it'll take a while here. Let's go look at the solutions that we got for, okay, here's the standard OPUS solution. And you know, it would be nice if this was a fixed font here, but it's not. But I want it to be in a fixed font. So what I do is I select the whole thing, copy, and then I go to Notepad. And this is going to be the standard OPUS solution here. And then let's go over and get this one. Yep, this is the beta solution, and we'll compare the difference between the standard and beta solutions. Boy, this is going to be a long video, isn't it? Got over here. Okay. So these are the same files, processed probably with the same stations, maybe not. Let's go down and look. So we got PAFM. Oh, I want to knock that one out. Well, we can do that later. PAW, yeah. So each of these solutions has one of the stations I don't want. I see I don't like this Burlington, West Virginia, and I don't like this McConnell Springs. But anyway, let's look at them and see what we get. Usually OPUS does a good job. Now remember, the left side over here is standard OPUS, and the right side over here is OPUS beta. So the first thing, let's look at the number used, observations used. So we got 82 versus 92%. So 92% is pretty good. I mean, this was done under a tree, perhaps. Fixed ambiguity, 80, fixed percent, 75. You know, this often happens if you have 90% used. Most of the ambiguities that you want to fix are bad and they're not going to get fixed. So that's probably reasonable. You'll notice the beta, the overall RMS is 2 centimeters versus 2.2. Not much difference, but come over here and look at the latitude. So latitude here is 13 and then 4, so 1.3 centimeters for the latitude on both of these. That's because there might be a tree to the south, right? So think about the satellites coming in. The satellites that generate a clean value for latitude are the ones to the south. In this case, we can't see them without a high signal of noise. But look, the longitude cleans up, and we're going to see a big change here on the ellipsoid height. So with standard beta, or standard OPUS, we've got a 6.1 centimeter. peak-to-peak error for the ellipsoid height. That translates into a 10 centimeter error for the orthometric height. It's not that good. But over here, using beta, we get it all the way down to 1 centimeter, which is pretty good. So the beta version here is pretty good. Now let's see if there's much difference. So the northing, let's use the state plane. So we're 630, 601, 630, 610. These are meters. So we are 9 millimeters difference. It's okay. Our easting, 815, 807. So there's a 8 millimeter difference there. I mean, it's actually, you know, if you're going to pick a set of numbers to use, you want to use the beta numbers because the peak-to-peak error estimates are lower. And so the difference between these two is certainly within the expected range of the peak-to-peak errors for the standard solution. So there you go. OPUS beta with full constellation rocks. At the top here, if you haven't seen one of these reports, you can see that we requested GPS, R is Russian or GLONASS, E is European or Galileo, and C is compass. Now, or Beidou. You can see here, I don't think any of these stations report Beidou. So we've only used Galileo, GPS, and GLONASS in our solution. But it's a lot better solution, so life is good. Anyway, thanks for watching this video. And if you bought a receiver from iGauge, thank you very much for buying a receiver from iGauge. We need your money. And if you have any questions about OPUS static, don't hesitate to contact me because I might have the answer. I see a lot of failed jobs, and I save a lot of failed jobs also. And I've been doing this forever. Anyway, thank you again. Have a great rest of your day, and good luck and good geodesy to you all.